Okay, now let's look at the other type of special problem. So that means we're going to focus on problems 3, 4, and 6, and 8. So again, let's do one like we normally would, and then we'll look at how we can find a shortcut. So we take A times C, so 1 times 49 is 49. I'm going to find factors of 49 that add up to equal 14. So I can do 1 and 49, but that doesn't work. Do 7 and 7, and that one does work. So 7 plus 7 is 14, and 7 times 7 is 49, so that one works. And then because the A is 1, we can go straight to our answer. For practice, let's go ahead and write out the long way though. So we would do that 1x squared plus 7x plus 7x. So those two numbers here go here, plus 49. And then we factor by grouping. So I can group the first two, group the second two. GCF is 1x. And then divide out that 1x, I get x plus 7. GCF here is positive 7. Factor that out, I get an x plus 7. So then there's my matching factor, that's one answer, x plus 7. And then my GCF, so the 1x and plus 7. And we notice they match this time, so we could even simplify this further and say that's x plus 7 squared. Okay, so it's always going to be like this with these special problems. And this, what makes it special is that this is a perfect square, so that's 7 squared. And then not only is that a perfect square, but if I take 7 and double it, we get the middle number, 14. So number 4, let's see what makes this one the special. 4 is 2 squared. 25 is 5 squared. And then with these numbers, you need to multiply these together. So 2 times 5 is 10. And double that should give us 20. Okay, so as long as all those things are true, then we can use a shortcut. If you're not sure if you can use the shortcut, or if you just can't remember the shortcut, then just factor like normal. You would do A times C, so 4 times 25 is 100. What factors of 100 add up to equal negative 20? And then continue the same process we just did for number 3. If you want to learn the shortcut, then once you figure out what those perfect squares are, you can just go right to your answer. So we'll set up our parentheses. And it's going to be very similar to what we did with like numbers 1 and 2. We have a 2 and an x in the front, so I need a 2 and an x in the front. Then I have that 5 at the end, so I need a 5 at the end. But the difference is we need these to both be the same sign. And that is because this last number is positive, so the only way to get a positive answer is 2 positives or 2 negatives being multiplied. And since this one needs to be negative, that means I'm going to have both negatives. So it's going to always match whatever that middle sign is. Like this middle sign was plus, and they were both plus signs in the middle. Okay, so let's try that with number 6. And number 6 is a special one because we have 9, which is 3 squared, 16, which is 4 squared, and then we can check 3 times 4 is 12, double that is 24. So we can go right to our answers. And then we have a 3 and an x in the front, so I need a 3 and the x in the front of each. Then we have that 4 at the end, so 4 at the end of each. And again, they have to be the same sign this time, and it's always going to match this one. So they're both going to be plus. And I can simplify, actually I should do it up here too. I can say that's 2x minus 5 squared, or I can write this one as 3x plus 4 squared. But then this one we have one more step because it's equal to 0. We're solving this one, we're finding the roots, which means I need to take that 3x plus 4 and set it equal to 0. I could do it twice, but because they're the exact same factor, I'm going to get the exact same answer. We're going to minus 4 from both sides. That's going to be negative 4. Then we're going to divide it by 3. So we end up with x equals negative 4 over 3. All right, and the last one, if I look at this, well, 12 is not a perfect square. Neither is 27. But again, if we're always used to checking for the greatest common factor first, or even if you think you can't do anything else, then try greatest common factor. I can actually divide all of these by 3. So then I can take a factor of 3 and x, because they all have at least one x. So then before I do anything else, I'm going to factor out that greatest common factor. So I'm going to divide them all by 3x. So 12 divided by 3 is 4. Then we subtract the exponents. 3 minus 1 is 2. 36 divided by 3 is 12. Subtract the exponents. And 27 divided by 3 is 9. And that one doesn't have an x. Okay. And then if I look at what's left over, I could factor this leftover part with the AC method. But I notice that this is 2 squared, so that's a perfect square. And this is 3 squared, that's a perfect square. And 2 times 3 is 6. Double that makes 12. So it fits our shortcut rule, which means I can go straight to my factors. And I have a 2 and an x in the beginning. I have a 3 at the end. And they're going to match this sign, so they're both minus. Just don't forget to bring down that greatest common factor that we factored out in the beginning. And I can simplify this even more and say that that's squared here since there's 2 of them. And again, since we're finding a root, so we're solving this time, then I need that 3x equal to 0. And I need that 2x minus 3 equal to 0. I could solve it twice since there's technically 2 of them, but again, you get the same answer both times. So here we're going to divide both sides by 3 and we get 0. Here we're going to add 3 to both sides. That makes it positive 3. Then we have to divide it by the 2. So we get x equals 3 over 2. But again, just like I said before, on any of these problems on this page, all of them, you do not have to use a shortcut. It's just that it is a shortcut. You could do the regular AC method for all of these and still get a correct answer.